Very good morning to all. Today we are going to discuss about the probability and Bayes theorem, which is a concept of open elective introduction to expert systems of AIML branch of second BTech SITRC Marshall. So what is probability? For example, we can say that today rain is coming. Today rain may come in the afternoon. So is it completely 100% true? Will the rain come? No, because there is a chance that similarly Ram can come tomorrow. That means there is a chance that Ram is coming to us tomorrow. So, but not sure which is 100% true or not. Similarly, that is the uncertainty can be defined by probability. Okay, the probability can be defined as a chance that an uncertain event will occur, but not completely. It may be occurring 30%, it may occur 50%, or it may occur completely. Okay, it is the numerical measure of the likelihood that an event will occur. It is the numerical measure that is varies from 0 to 1 of a event that likelihood to occur. The value of probability always remain between 0 and 1 that represent ideal uncertainties. If probability is 0, completely the event may not occur. If probability 1, there is a chance of 100%. Okay, like that. So we will measure the occurrence of the event in the percentage. That is nothing but probability. So P of here 3 points. The probability of an event will always be between 0 to and 1, and the probability of A is equal to 0 means the event A there is totally uncertain, completely uncertain, may not happen. That is P of A is equal to 1. The event A, there is a completely certainty about its happening. Okay. Next, we can we can find the probability with some formula of an uncertain event. Probability of occurrence of an event is equal to number of desired outcomes which are favorable in the event and total number of occurrences or total number of outcomes. Okay. For example, if I throw a dice, dice is having 6 faces. Each face is having a marked with one dot. So there may be total number of outcomes that upper face is 6 number. Either upper face can contain 1 dot or 2 dots or 3 dots or 4 or 5 or 6 dots. But I want that only I want an event that the dice will result in 3 points. So what is the desired outcomes here? 1. Desired outcome is 1 only, and total number of outcomes is 6. Therefore, probability of appearing a 3 on dice is equal to 1 by 6. So the probability of an event is represented by P of A, while probability of not happening an event is represented by P of negative A. P of negative A. Okay. So like this it can be represented. Whereas the probability of occurring plus probability of not occurring of an event A is always equal to 1. Okay. In this one, we can came across different types of terms. So one is the event. Event is a possible outcome of a variable. Simply, sample space. The sample space is nothing but collection of all possible events of a particular scenario. Random variables. Random variables are used to represent the events and objects in the real world. Okay. Prior probability. The prior probability of an event is probability that computed before observing new information. So already the information is uh, available for that one. So that is known as a probability. If the information prior to the event is available and event is to be calculated, then that is known as a prior probability. And we can also have posterior probability, the probability that is calculated after all evidence or information has taken into effect. This is a combination of prior probability and new information. Okay. Next, the next term is the conditional probability. See, conditional probability is a probability of occurrence event when an event is already happened. For example, if the event B is already happened, okay, we want to calculate event A with respect to B. So that is defined as the probability of A under conditions of B. That is symbolically represented as P of A slash B is equal to P of A and joint the P of A joint B, that is joint probability of A and B. Okay, under occurrence of probability of B. Clear? P of A joint B under the probability of P of B. Okay, this is known as a conditional probability. This is very, very important in the concept of expert system design, the conditional probability, because based on this one only we are going to study about the Bayes theorem or Bayes rule. See, now if the probability of A is given, and if you want to calculate or if you want to if you want to find out the probability of B, then it will be given as P of B by A is equal to P of A joint B divided by P of A. That means here the this conditional P of B by A means the probability of B is to be calculated when probability of A is already given. While the P of A by B means the probability of B is already given and we need to calculate the probability of A under conditions of the P of B. Clear? So it can be explained using the below Venn diagram. When B is occurred event, so some sample space will be reduced to set B, and now we can only calculate event A when event B is already occurring by dividing the probability of P of A joint B by P of B. Okay, so we will apply this formula for some results, some of the problems. In a class, in a class, there are 70% students who like English and 40% of students who like English and mathematics. And what is the percentage of students, those who like English also like mathematics? So let us take that there are two cases. First case is A. A is nothing but students who like English only, 70%. Okay. And second case is the student who likes English and mathematics, 40%. Okay. And what is the percent of students, those who like English also like mathematics? So English we need to take, okay, the number of students or percentage of students who like both the events is P of A joint B. The percentage of students who like uh, English only, 70%. So P of A by B is equal to this P of A joint B divided by P of B is equal to 40% divided by 70% is equal to 57%. That means 57% of students, okay, like English, also like mathematics. So this was mathematically proven with the help of probability. And this next concept is the Bayes theorem. The Bayes theorem or is also known as a Bayes rule or Bayes law or Bayesian reasoning, which determines the probability of an event with uncertain knowledge. In probability theory, it relates the conditional probability and marginal probabilities of two random events. Okay, Bayes' theorem is proposed by the British mathematician Thomas Bayes. Bayesian inference is an application of Bayes' theorem, which is fundamental to Bayesian statistics. It is a way to calculate the value of P of B by A. Okay, with the knowledge of P of A by B. That means if we know the conditional probability of A with respect to B, we can able to find out the conditional probability of B with respect to A. This is the main specialty of Bayes theorem. While before rule, this one, the conditional probability is only limited to the combined joint event, joint probability as well as original probability. But in this Bayes theorem, if we know P of A with respect to B, we can able to calculate P of B with respect to A. That is specialty. So, for example, we consider some example. Before considering this example, so let us see that some terminology. Let us say that P of B by A is called likelihood, in which we consider that hypothesis is true. Then we calculate probability of evidence. P of A is nothing but a prior probability because A is already occurred in this one. In P of B by A is already occurred. That's why A is known, P of A is known as a prior probability. Probability of hypothesis is before considering the evidence. So P of B is called marginal probability. Okay, pure probability of an evidence. So just let us remember these two words, that is prior probability and marginal probability. And now we will see the example. If cancer corresponds to one age, then by using Bayes theorem, we can determine the probability of cancer more accurately with the help of age. Bayes theorem can be derived using product rule and conditional probability of event A with known event B. For example, uh, from P of B, from see this, just a minute, just a moment. See, already we had seen one formula before. What is the formula for P of A by B? P of A joint B divided by P of B. From that, P of A joint B can be calculated written as like this. Similarly, from P of B by A, we are having a P of A joint B divided by P of A. So from that one, this second equation can be written. So equate these two equations. These two equations are same. Equate the RHS, right hand sides of the both equations. Then we can able to calculate we can able to write P of A by B into P of B is equal to P of B by A into P of A. From that one, P of A by B is equal to P of B by A into P of A divided by P of B. So this is known as a Bayes rule or Bayes theorem. This equation is basic modern AI systems for probabilistic interference. It shows the simple relationship between joint and conditional probabilities. Here P of A by B is known as a posterior, which we need to calculate and will be read as a probability of hypothesis A when we have occurred an evidence B. So the rule can be extended to a number of events. For example, if the number of events are more, then we can expand that particular formula Bayes rule like this. For example, if we want to calculate P of A by B, when more number of events which are mutually exclusive are there, then we can use P of AI into P of B by AI divided by sigma I is equal to running from 1 to that number of events P of AJ into P of B by AJ. Okay. So this is the extension of the Bayes formula. And how to apply Bayes rule? This Bayes rule allows us to compute single term P of B by A in terms of P of A by B, comma P of B and P of A. So in our convenient case, we can write it as a P of cos by effect is equal to P of effect by cos into P of cos divided by P of effect. So this is most important. We can remember this is most important, this formula, because if we don't remember that earlier formulas, this will be helpful. P of cos per effect is equal to P of effect for cos into P of cos by P of effect. Okay. So now we will see some of the examples. One example we will see. You know, play cards. The play cards, we are having a 52 cards. The 52 cards are divided into four categories. Okay. The four categories, in each category there are 13 cards are there. So the given question is, from a standard deck of playing cards, a single card is drawn. The probability that card is king is 4 by 52. Then calculate posterior probability P of king by face. It means that drawn face card is a king card. So here uh, the probability that card is being a king is the prior probability. Okay. Then what is the posterior probability P of king by face, which is nothing but P of king by face is equal to P of face by king into P of king by P of face. So what is this P of face by king? If card is taken, if that is king, if that is king, the card being a face is equal to 1 only. So that's why here 1. Okay. Whereas the probability of taking the card being a king is equal to 4 by 52, because 4 kings are available in 4 sets. Probability that card is a face card is equal to 3 by 13, because in every set there is a 3 cards which are belonging to face. Okay, so putting all these values in the above formula, we will get P of king by face is equal to 1 by 3. This is the probability that the face card is a being king. So this is the application of the Bayes rule. So, and one more, the Bayes theorem is also used to calculate the next step of the robo when already executed step is given. This is very important while designing the neural networks, robo, neurotic schema, etc. Bayes theorem is helpful in weather forecasting. Bayes theorem is helpful in weather forecasting. And Bayes theorem can solve the Monty Hall problem, which is a familiar problem in the this particular probability and statistics. Okay, so these are the applications. So if you are having any clarifications, you can always welcome to clear that resolutions. Thank you.